Hello, everyone. So today what we're going to do is continue our unit on triangle congruence. In our previous video, we discussed that if two triangles are congruent, then all corresponding angles and sides are congruent. However, sometimes they're not going to give us all angles, all sides. They'll only give us two angles and two sides, or all three sides is fine, or they'll give us two sides and one angle. So we will use that information to determine if triangles are congruent. Now, there are a few different ways to determine if triangles are congruent, and we're proving they are congruent. So we're going to be doing some proofs today, which is new. All right, so the first two ways to tell if triangles are congruent is if all three sides are congruent, or two sides and an included angle. Included means the angle is between the sides. See how we have side, angle, side. So if we look at our picture here, we can see there's two sides marked congruent and then the angle between them, two sides, angle between them. We will go over the other three in the next video. And then down here at the bottom, of course, is our CPCTC corresponding parts of congruent triangles are congruent, which is, of course, what we talked about in the previous video. Now today, again, we're going to be working on proving that triangles are congruent, not just by information they gave us, but by information that we can determine based on that information. So they're not going to give us every piece of information we want. We are going to have to be Sherlock Holmes and deduce some of this information based on things that we know. So here are the lists of reasons we're going to be using in our proofs today for reasons sides are congruent and reason angles are congruent. So there's three things that we can use for reasons sides are congruent. Of course, they can give us that information. They can also tell us that, say, a point is a midpoint, which gives you two congruent pieces. So definition of midpoint. And reflexive property. This means a side or anything else is congruent to itself. A equals A. So 1 equals 1, 2 equals 2, AB equals AB. So reflexive property, we're going to be using that a lot. Okay, so now we have a list of reasons angles are congruent. Now you can see there's a lot more reasons, but that's because we have these four angle relationships we can use. So of course we can be told that angles are congruent. And of course we can do a bisector, definition of angle bisector. A bisector creates two congruent angles. If we're told that a segment is a bisector of a line segment, we can also use that. And then, of course, we have our vertical angles, which are angles across the intersection from two crossing lines. Alternate interior angles, alternate exterior angles, and corresponding angles. Now, it is important that they tell us that two lines are parallel in order for us to use any of these. So let's give it a shot and do some practice. All right, so let's go ahead and fill in our blanks. If side A, so let's go with AB, is congruent to DE, and then we want to go with the next side, BC, and we can see that that is congruent to EF. And then finally, if the last side is AC, is congruent to DF, then it's side, side, side. All three sides are congruent. So that means the triangles are congruent. Now we need a valid congruent statement. So if we look here, we can follow our path. I'm going to say angle A. And if I go along the one tick mark line, I get to angle B. And then if I continue following along past the two tick mark line, I get to angle C. So we do that same pattern over here with DEF, D. We're going to follow along the one tick mark, and we get to E. And then finally we get to F. So we can have any order as long as they are in the same order on both sides. So I'm just going to say ABC and DEF. You could say BCA and EFD. You could say CAB and FDE. You could say ACB and DFE, as long as they're in the same relative order. When you have finished with this section, please make sure you click that checkbox right there and go ahead and move on to the next section. All right, so let's go ahead and move on to sample side proofs. Okay, and what I like to do is mark the given information on the picture that they've given me for my problem. So in this case, they tell me that segment PQ and segment ST are congruent. Okay. They also tell me that QR and TR are congruent. And then they tell me that R is the midpoint of segment PS. So what that tells me is that PR and RS are congruent. And they want me to prove that PQR is congruent to STR. So how do we do that? Well, first we're going to fill in these blanks. So how did we know that PQ and ST were congruent? Well, they told us. So that's given information. So the same thing is true about this number 2. QR is congruent to TR. They gave us that information. And again, that R is the midpoint. That is also given information. Now, I have seen people do proofs where they'll put all the given information into one box. That's fine. We're not going to be doing it that way. We will always have a box per statement. All right, number 4 here says that segment PR is congruent to SR. Why did we know that? Because that is the definition of midpoint. Okay, that is the definition of midpoint. And then we're saying these two are congruent because all 3 sides are congruent. So we say side, side, side. And that's all you have to do for that. Make sure you select that you've completed the section. All right, next up we have number 2. It says given that JL and NM are congruent. Okay. So we know that these two are congruent. And it tells me K is the midpoint of JN, which is this one. So I'm going to mark JK and KN. And it is also the midpoint of LM, which is this one right here. So we're also going to mark LK and KM congruent to each other. And again, they're being very kind. They're telling us the statements. Again, here we go. We are given that JL and NM are congruent. We are given that K is the midpoint of those two segments. Now, the reason JK and NK were marked congruent is that's the definition of a midpoint. And then again, same thing as to why LK and MK are congruent. It is again definition of midpoint. And again, that means that all 3 sides are congruent, so therefore these 2 triangles are congruent by side, side, side congruency. Now, you may have noticed that there are vertical angles here, where we have this one right here and this one right here. However, without some of this other information, it wouldn't have done us any good. So we need to make sure we have the correct information in order to prove that 2 triangles are congruent. Make sure you go ahead and mark this section as complete and move on to number 3. Now you'll see this one is technically blank on both sides, but I went ahead and filled in 1, 2, 3, 4 on the reasons for you for the math part, and we can fill it in. So again, we're going to go through what they give us, and then we're going to mark it on our triangle picture here. So first of all, they tell me that AC and AD are congruent. CB and DB are congruent. And then we know that AB is congruent to itself. That's always true. And I've noticed that every single one of our online resources will mark it with an X when it's congruent to itself like that. So that might make it a little easier to see. All right, so now we're going to fill in these statements. So the first thing that we know is that segment AC is congruent to segment AD. And again, we know that because that was given information. We know that CB is congruent to DB. And you'll notice that you have to either be in the equation tool to change these equations, or if you go in the select tool with the arrow, you can click inside them. That might be easier. Okay, so again, this is given information. Now, it doesn't say anything here. Now, even though we know AB is congruent to AB because it is, itself, that information is not given to us. We have to actually deduce that information. I know that seems silly. So let's look again at our reasons that things can be congruent in geometry. We have it's given, definition of midpoint, or reflexive property. A side is congruent to itself. So all we're going to put here is reflexive property. On the key to this, I have put in parentheses, side is congruent to self. I think you should include that just because it will make it easier for you to remember, at least on one of these. All right. And now we have all three sides are congruent. So let's go ahead and go right here. Triangle ABC is congruent to triangle ABD, and that is by side congruence. And you do not have to type out side. You can just put SSS. That is normal. Please go ahead and mark this section as done when you have completed it. All right, now side congruence is the easiest to understand. It's pretty simple. If all three sides are the same, then the two triangles are identical. But again, they do not always give us all three sides. Sometimes they'll give us angles. So we're going to focus on angle side now. This tells us that if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So using this image here, if segment AB is congruent to segment DE, and we have our one tick mark and our one tick mark, and then our angle, we have our arc, so angle B is congruent to angle E. Again, notice these angles are in between the sides. The angle is in between the sides. All right, and then we have BC is congruent to EF. You'll notice that the included angle includes the endpoint of the segments that are joining the two that are congruent. Okay, so if these three things are true, AB is congruent to DE, B is congruent to E, and BC is congruent to EF, then ABC is congruent to triangle DEF by angle side angle. Okay, again, included means the angle between the sides. It's super important. You'll notice that if you look at the cheat sheet, I put angle is between the sides. It is on here for you. Please go ahead and take a moment, mark this section as complete. All right, now let's go ahead and do a few proofs to see what we can pull off with this. So first off, number 4 here tells us that segment JM and LN are congruent. So that's this one right here and this one right here. Now you might want to eyeball this and say, oh, well, JNLM is a rectangle, so of course all these sides are congruent. It doesn't give us that information. We cannot assume that just by looking at it that this is a rectangle, okay? All right, so we have angle JMN. JMN is congruent to angle LNM. So we start LNM. Now, this actually is enough to tell us that JN and ML are parallel because alternate interior angles are parallel. But we don't worry about that right now. And then we're going to mark MN congruent to itself by marking it with an X. It's always a good thing to do is make sure you mark that the side that is congruent to itself. That is the side that is the easiest to forget exists, is the side that is congruent to itself. All right, we know JM is congruent to LM because that was given information. We know these angles are congruent because, again, that was given information. And we know that this side is congruent to itself. Again, anytime we see that something is congruent or equal to itself, that is the reflexive property. It works in algebra and geometry. Remember, A equals A, X equals X, B equals B, C equals C, 1 equals 1, 2 equals 2, -1 equals -1. All of those things are examples of the reflexive property. Something is always equal or congruent to itself. With that in mind, we can say these two triangles are now congruent by side, angle, side. Okay, one, angle between them, side, side angle, side. Make sure you mark this section as complete, and then we will move on. All right, number 5 here. On this one, I'm going to go ahead and mark that for that congruent, shared side congruent, just so it's not the last thing I do. I actually do prefer for that to be the first thing I do. Now, it tells me that AB and CB are congruent. Now, if we were doing a long, drawn-out proof, we could then prove that angle A and angle C are congruent because ABC is now an isosceles triangle. But we're going to focus on the fact that segment BD bisects angle ABC. That's this one right here. So let's go ahead and fill in the reasons. First off, it asks us, why is segment AB congruent to segment CB? Well, that is because that information was given. BD bisects angle ABC. That was also given information. We are told these two angles are congruent. So again, let's look at our cheat sheet for reasons. Reasons angles are congruent. We were given a bisector information. So we can say definition of angle bisector. Now again, you can also abbreviate things. You can put def of angle bisector, def angle bisect. It's whatever you need to put. And then again, BD is congruent to BD. Anytime anything is congruent or equal to itself, we will say that that is the reflexive property. And again, now we have side, angle, side, side, angle, side. And those are going to be our congruent statement there. These are congruent by side, angle, side. Mark this section complete, please, and we will move on to the next one. All right, number 6. Let's take a look. First thing I'm going to mark is that angle YVZ right here and angle WVX right here. I'm going to mark that those congruent. They're vertical angles, and I am going to have that information. V is the midpoint of WZ and XY. So let's look at the WZ. So V is the midpoint, so it bisects this line. And then it's also the midpoint of XY, so these two segments bisect each other, which is nice. Now that's also another thing they could have told us. If a given had said that WZ and YX bisect each other, that would have given us the same information as V is the midpoint of both segments. All right, let's go ahead and fill in our proof. V is the midpoint is given information. That is the only thing that was given to us. That WV and ZV are congruent is the definition of a midpoint. And that is, I would have actually, if I was doing this by hand, this one right here, VX or XV and YV being congruent would actually be on line 3 because it's also tied to the given information. That's just my preferred way to do it. I like to keep the given information together, but you don't actually have to. Now, the fact that these two angles, WVX and ZVY, are congruent is vertical angles are congruent. And all you have to do is put vertical angles. And then again, we have side, angle, side, side, angle, side. And we just put SAS. Click, I have completed this section, and move right along. All right, so last one on this notes. I'm going to go ahead and mark the shared side congruent. HJ is congruent to HJ. Again, that's just my preferred preference. They tell me that HI and JG are congruent. And then they also tell me that those are parallel segments. And yes, that is important. Because if HI is parallel to GJ, that means IHJ right here and HJG are also going to be congruent. And that is because they are alternate interior angles. And we do have a spot for that. So again, HI being congruent to JG was given information. HI being parallel to GJ is also given information. GJH and IHJ being congruent is because alternate interior angles are congruent. Then you don't have to put alternate interior angles are congruent. You can just put alternate interior angles. HJ is congruent to JH, and again, that is reflexive. It's the same line. And again, now we can say that these two triangles are congruent by side, angle, side, side, angle, side. So they match. Mark it as complete. And now that once you've completed this page of notes, turn it in on Google Classroom. Make sure it gets turned in on Google Classroom. We will be doing an assignment where you will again have some fill in the blank statements to prove side angle side and angle side angle. Side angle side and side side side. I will also be posting some YouTube videos that have the mnemonics ready for you. They can be annoying, but they're sometimes fun. So I will see you soon and have a great day.